Welcome to the Unit 3 remediation for our guided practice. Starting with these questions, let's start with number 1. It says rank the models of the atom from least to most accurate. So when we're looking at these, we're really talking about main ones are going to be the first one, which is Dalton. And Dalton was a theory, or it was the first theory that was empirically tested, least accurate. Moving on from there, we have J.J. Thomson, which discovered the electron and became a little bit more accurate. And then we have our Ernest Rutherford, which discovered the nucleus and became a little bit more precise. And then lastly, the one big one that we really deal with is talking about Niels Bohr, which determined the energy levels. Between each model describe the experiment. So how did they find these things? So when we're talking about Dalton's theory of the atom, that he used different gases to determine that there was an atom or a thing of atoms. And then moving on from there, J.J. Thomson used cathode ray tubes to determine that there were positively and negatively charged particles. And then Ernest Rutherford, with the Rutherford Gold experiment, determined that there was a dense, positively charged nucleus with the electrons surrounding it. And then we can look at Niels Bohr, talking about the quantized energy levels, looking at the energy level diagrams, talking about absorption spectrum and everything else that discovered the quantized energy levels. 3, it says between each model describe the new knowledge gained from the experiment. What we've said before, that Dalton was just the first that said that there was an atom and he empirically tested it. And then there was J.J. Thomson that said that there were positive and negatively charged particles. And then we have Ernest Rutherford that said that there is a dense packed nucleus with electrons surrounding it. And then Niels Bohr said that there were quantized energy levels, meaning very specific energy levels for those electrons to be in. So when looking at protons, neutrons, and electrons, just describing the effect on the atom, when we add or remove electrons, we are creating ions. We can either go positive or negative. If we add an electron, we become negative. If we remove an electron, it becomes positive. Adding or removing a neutron means that we add or remove mass. So all it does is change the mass. Doesn't change the charge or what it is or anything like that. Just changing the mass, more specifically changing what isotope it is. And lastly, protons. When we have protons, the impact on the atom would be telling you what the atom actually is. Our periodic table is designed with the number of protons. Looking at number 5, it says determine the number of protons, neutrons, and electrons in the following. So we'll start with C and D on these and kind of leave you with A and F to look at. When we're looking at what we would call C and D, it's nuclear symbol notation. And so what we have is we have the mass number on top, the very top, and then we have the number of protons on the bottom. So when we're looking at this, since it does not have a charge out here, we say that the protons equal the electrons. So we would say we have 92 protons and we have the same number of electrons. Now to find the neutrons, all we do is 235 minus 92, which is going to give us number of neutrons, which is 143. So we have 143 neutrons. Now with D, what we're looking at is still we have our mass number, which is here. We have our protons, which are there, but we have a charge out here. And really when we think of it, it's protons minus electrons equal the charge. And so since we have a positive charge, which is essentially plus 1, when we're looking at this, we have 1 proton, because that's a 1. That means we go what minus 1 minus something equals positive 1, and that would have to be 0. So we would have to have 0 electrons. So we have protons, we have 1, electrons, we have 0, and neutrons, 3 minus 1 would be 2. Now with these other two guys that you're going to do on your own, we're looking at the periodic table. And since I don't give you a specific mass number, take the atomic mass, round it to a whole number, and then you can use that as your mass number. Remember, pay attention. You got a little charge out there on B, so try those two. Moving on to ionization. It says, what is the difference between an ion and an isotope? An ion has a different number of electrons. An isotope has different number of neutrons. Number 7, it says, how can you ionize a substance in the lab? Sending electricity through something can ionize it because electricity is electrons. And when we're really thinking about it, if we have like a salt solution, you can separate a salt out into its positive and negative charges just using the positive and negative on a battery. Number 8, it says write the ionic notation for the following. So we're writing the ionic notation. Protons tell us what it is, and then we go protons minus electrons to find charge. So 3 protons, we know that we have lithium, and 3 minus 2 gives us positive 1. 9 protons tells us that we have fluorine, and our charge would be 9 minus 10, which is negative 1. And then 11 protons would be sodium, and then 11 minus 10 would be plus 1. Moving on to atoms, ions, and isotopes. Calculate the average atomic mass or percent abundance of the following. It says, what is the average atomic mass of the unknown element that has 2 isotopes? So our unknown is just that X doesn't matter. It's just an unknown. We have X29, which is 14%, and then X33, which is 86%. And so all we do is, this is the mass number. We multiply it by the percent and add them together. So what this looks like is 29 times 14%. Now remember to move the decimal 2 places, and we get 0.14. Add that to 33 times, move the decimal, 0.86. We add all of those together, and we should get an average atomic mass of 32.44. Number 5, or B on that, says what is the percent abundant of each isotope of chlorine when chlorine has been shown to have an average atomic mass of 35. Now when we're looking at this, we can use the problem above to kind of look at each piece. So we have chlorine 35 and chlorine 37. Well, that is a mass, that is a mass. So it would be set up just like that. And that would go there. And we have an average atomic mass, which is right there. Now, what we don't have is we don't have the percentages. And so to find those, what we do know, if I only gave you one of these percentages, and I said that on X33 that you had 86%, you would know that, well, the other one would be 100 minus 86. Well, in percentage, what we're going to do is we'll set it up with 35.5 equals our mass, which is 35, times our percent, which we'll just call that percent Y, plus our 37, which is the other mass, times, now whatever Y is, we know that the other percent is just going to be, and we're going to put it not in percent form, but in decimal, 1 minus Y. And so what we'll do here is we can go ahead and solve for Y, and Y will give you the percent of our chlorine 35. On the next one, it's a little bit easier one. You're just solving just like you did in A, but you're looking for an unknown element. So find the average atomic mass, look at the atomic masses on the periodic table that match it, and then you found your unknown element. Now looking at the periodic families, it says in number 10, use the periodic table to answer the questions below. So when we're looking at the periodic table, it says name the family on the top of the periodic table. So when we're starting over here, we see that we have the alkaline metals, and then we have the alkaline earth metals. Then we have the transition metals. And then really the only really nonmetals that we're really concerned about are the halogens, and then the noble gases. Then on the bottom of the periodic table, we have the lanthanides right here. And then on the bottom, very bottom, we have the actinide. B, it says, what is the ionization of each chemical family? So for our alkaline earth metals, or alkaline metals, which are these guys right here, it's going to be +1. Alkaline earth metals will be plus, um, +2. And then really when we're getting over here, this, and just important to know, is +3, plus or minus 4, and then group 15 is -3, 16 is -2, 17 is -1. Just some things we need to know for later on. And lastly, it says list the properties of each chemical family. The big ones to know: alkali metals are most reactive metals. Halogens are most reactive nonmetals. Those are some big ones. We know that the noble gases don't react to anything. They are unreactive. And then you can look up in your notes each about the different other chemical families.